Chapter 4, Section 3 is about parallel and perpendicular lines. The main thing I want us to be able to understand in this section is what's the difference between a parallel and a perpendicular line, like what makes them the way that they are, and how can you tell if lines are parallel or perpendicular based off of their slopes. So parallel lines would be lines that never intersect or never cross. They're going to have the same slope. The symbol for parallel lines is like these two bars that kind of stand straight up and down next to each other. Perpendicular lines mean that they have opposite reciprocal slopes. That means that they have opposite signs, so one would be positive and one would be negative. And reciprocals would be when you look at the slope as a fraction and you flip it upside down. Both of those things have to happen in order for lines to be considered perpendicular. For example, if I have a line that has the slope 2/3, the perpendicular slope would be a negative 3/2. See how the sign changed and see how they flipped my fraction upside down. The symbol for perpendicular is an upside down T. So if you guys see those symbols, or if you see me use them, that's just my way of kind of shorthanding to tell you like what type of lines that we're dealing with. So for example, what they might have us do is decide if lines are parallel or perpendicular. And they might just give you lines, and then some of it is going to be you can look and see, but they might want you to like kind of justify how you found your answer here. So in order to do this, I would want to find the slope of your lines. And you can find your slope by using your slope equation. And then you want to compare the numbers that you get. So if they come out to be the same, that means that they're parallel. If they come out to be opposite reciprocals of each other, that would mean that they're perpendicular. So for example, for this one, I've got these two lines CE and A through D through B. Now, in order for me to find the slope, because they already gave me those answers here, what I did is I either, used my methods of like counting on the line. So like I went up 1 and over 2, and that's how they got 1/2. Or they would have grabbed coordinates. So like C is at 1, 4. E is at 3, 5. And they would have plugged that into my slope equation. So I would have said like 5 minus 4 over 3 minus 1. And I would have gotten the same 1/2. Now they could have done the same thing with that other line. They could have either said like I went up 1 and I went over 2. Or they could have plugged in 2 new coordinates for A and D or D and B, whatever points they pick. And they got 1/2 as well. And so we got that those lines were parallel to each other. So the thing that you're going to have to do with these types of problems is figure out what the slope is of the lines, either by kind of counting on your graph like we've done in the past, or using your slope equation, and then looking at those slopes and deciding if you think they're parallel or perpendicular or neither. So there's a couple of practice problems here. We've got several lines kind of entwined in this one graph here. They want you to decide if the lines are parallel, perpendicular, or neither. So we're going to do this first one together, and then you're going to try one on your own. So for this first one, they're comparing lines EB and CD. So that would be these lines that I'm highlighting in yellow. Now you might already have an assumption that those lines are parallel because it doesn't look like they're going to cross. But let's do the work to find the slope to see why they're parallel. So for EB, I would have looked at those coordinates. Okay, so E is at 3, 5. B is at 4, 2, or 4, 3. And so I would have done 5 minus 3 over 3 minus 4. And that got me 2 over -1, which is -2. Now you can do the same thing then for the other line, CD. And so C is at 1, 4. D is at 2, 2. So I would have done 4 minus 2 over 1 minus 2. And I got 2 over -1, which is still -2. So looking at these two numbers, they are the exact same, which tells me that these would be parallel lines. So it's just kind of justifying the answer, because when I looked at them, I thought that they would be parallel just by how they looked. but by actually doing the slope and like doing the work behind it, that's how we can kind of confirm that they are parallel lines. Now, there's another practice problem here. Using the same lines from up above, I want you to decide if lines EB and DB are parallel or perpendicular. Now, we already did the work for EB up above, so I'm not going to redo all of that. I'm just going to use what I know about EB and say that that's -2. But for DB, you did need to do a little bit of work there. And so what I plugged into my equation was 3 minus 2 over 4 minus 2. So 3 minus 2 would be 1, 4 minus 2 would be a half. If you look at these two slopes, I've got -2 and I've got positive 1/2. So they are opposite because they have opposite signs. One's negative, one's positive, and they're reciprocals. Because if I were to flip these around as a fraction upside down, they would be reciprocals of each other, which means that these lines should have been perpendicular. Now, another situation that you might have is if they actually just give you the equations of a line instead of giving you lines that are graphed and asking you the same thing. Are they parallel? Are they perpendicular? So when you're dealing with a problem like this one, you need to look at where the slopes would be. Now, both of these equations are in slope-intercept form. They're in that y equals mx plus b form. So remember that your slope would be the number that's in front of your x. So the 3 is your slope for both of them. Since they're the same, that would mean that these lines are parallel. Now, the second equation down here, those aren't in slope-intercept anymore. They're in point-slope form, which is this equation. So I want you guys to do the same thing. I want you to identify the slope and then decide what type of lines you have. So your slope for the first line should have been 5. Your slope for the second line should have been -1/5. They are opposite signs. One's positive, one's negative. The reciprocal of 5, if you think of that as 5 over 1, would be 1 over 5. So that makes these lines perpendicular. Now, the next example here wants me to create an equation that goes through a specific point, and I want a specific slope based on the other equation that they already gave me. So for this first one, they want me to create an equation that's parallel to the given line and goes through the point provided. Remember that parallel lines have the same slope. So the equation I have is y equals 1/2 x plus 2. So if I'm dealing with a parallel line, that means that my slope needs to be the same. Now my slope of this line is 1/2, so I don't want to change my slope at all. I want to leave it as 1/2. Now this point that I'm going through 3, 7, think of that as like your x1, y1, and think of 1/2 as your slope. And so they took both of these pieces of information and they plugged it in to my point slope form. So this is what we talked about in section 2. So they did y minus 7 for the y1 equals 1/2 for your slope times x minus 3, and that came from the x1 up here. Now, if I needed to rewrite this so that it was in slope-intercept form, I could. So what I did then is I distributed the 1/2. This is what we were doing at the end of section 2. So I got y minus 7 equals 1/2 x minus 3 over 2. And then I added 7 just to the -3 over 2. And that's how I got y equals 1/2 x minus 11 over 2. So there are 2 practice problems at the bottom of this page. They want you to do similar things here. They want us to write equations that are parallel to the line that they gave us. So they're giving you a line. I will say for the second practice problem, make sure that you solve this for y first before you try to write your equation. So pause the video here, take some time to work through those 2 examples, and then come back to see what your answer should have been. So for this first practice problem, that 3 over 2, that's your slope. That's what we want to keep it as. And this 0, 1 would be your x1, y1. So I wrote it as x minus 1. Sorry, not x minus 1. Y minus 1 equals 3 over 2 times x minus 0. Then I distribute the 3 halves. So I have y minus 1 equals 3 over 2x, and then 3 over 2 times 0 is just 0. Then I needed to add 1 over here. And again, you can think of this as like plus 0 if you need to. So the equation should have said y equals 3 over 2x plus 1. For the second one, you needed to solve for y first. So I would have done minus 2x. We've got negative y equals negative 2x plus 1. Then I would have divided everything by a negative 1 to get the equation y equals 2x minus 1. And then we can begin to write our equation. So now that we've got our equation rewritten so that it says y equals 2x minus 1, and I'm still trying to write a new equation that's parallel, I want to pull my slope from this line, which is going to be 2, and then this would be your point x1, y1. So I'm going to start by using point slope again, so it's going to be y minus 0 equals 2 times x minus 1. Then I can distribute the 2. And over here on the left, it says y minus 0, so that's just going to be y equals 2x minus 2 when I distribute, and that would be my equation right there. Now, the last example here is similar to that last one, except they want you to create an equation that's perpendicular, so not parallel anymore. Again, they're going to give you some of the same information, like they're going to give you a line with a slope and then a point that it has to go through. Now, a key thing to remember is that perpendicular lines have what we call opposite reciprocal slopes. So you will have to change your slope on these types of examples. You'll have to switch the sign and you'll have to flip your fraction upside down for that reciprocal. So for this example I have worked out here, we start with the line y equals 2/3 x. So my slope of this line is that 2/3. Now, because I need a perpendicular slope, that means I'm going to change this from positive to negative, and I need to flip my slope upside down. So instead of 2 over 3, it's going to be 3 over 2. And then that point, the negative 1, negative 2, that's still going to be my x1, y1 point, and I'm going to put that in now to my point slope form. So they've got it written here, y plus 2. Remember when they started this, or like if we had started this, we would have written it as y minus a negative 2, and that's why they're writing it as plus 2, because we get rid of those double negative signs. And the same thing happens with the x minus negative 1. They rewrote that as x plus 1, again, just to kind of clean that up and make it look a little bit nicer. So what they did then next is similar to what we were doing on those previous examples. Once you've got like those pieces of information plugged in, the work to get to your equation is the same. You start by distributing into the parentheses to clear those out, and then they subtracted 2 from that fraction negative 3 over 2 to get that negative 7 over 2 for your final answer down here. So for this last practice problem here, you're going to do the same thing. So you're going to try to find the perpendicular slope. So for this first line here, remember this negative 1/2 is the starting slope. So your perpendicular slope needs to be opposite reciprocal. So it's negative right now, which means that my new slope is going to be positive. And 1 over 2, we would flip that upside down. So it's 2 over 1, or just 2. Then this 2, negative 1 would be your x1, y1 point. So we would do y minus negative 1 equals 2 times x minus 2. Now the double negatives here, you can switch that so it says y plus 1. Now I'm going to go ahead and distribute my 2. So this side says 2x minus 4. Then I'm going to subtract 1. So my final equation says y equals 2x minus 5.